We're going to look at absolute values and the unit circle all in one go. So when I say absolute or exact values, I mean values for sine, cosine, and tan. Now, 0 and 1 for all these different things are easy to work out with unit circle. So for our absolute value straight away, I'm going to use our three nice values at 30 degrees, 45 degrees, and 60 degrees. Now what I want to do is find absolute or exact values for sine, cosine, and tan. The easiest way to do this is to remember the values, the exact value of that is nice to work with. So I'm going to start with sine of 30 degrees. I know that sine of 30 degrees is equal to exactly 1/2. I've remembered that. I'm also going to write my SOHCAHTOAs up here. They're going to be important later. I know it's a half. Now, if I was to put that in a right angle triangle, here's my right angle triangle. Sine is opposite over hypotenuse. So I'm going to say my angle's down here, my 30 degrees. I know that opposite in this instance is 1, and the hypotenuse is going to be 2. Okay, so sine 30 equals 1/2. All I've done is sine 30 is opposite over hypotenuse, 1/2. With this, I can work out this bottom value using Pythagoras. A squared plus b squared equals c squared. So I have 1 squared plus b squared equals 2 squared. So I know this value down here is actually going to be √3. From that, I can work out exact values for sine 30, sine 45, and sine 60 pretty easily. Now, I say sine 60 because if that's 30 and that's 90, it means this angle here has to be 60 degrees. Okay, well actually it's only sine 30 and sine 60. 45 I'll do that later, sorry. So if I had sine 30 equals 1/2, I'm going to have a look and think of what cos 30 would be. Now cosine of 30 is adjacent over hypotenuse, so it's adjacent over hypotenuse, so I have √3 over 2. Now let's do tan of 30 as well. Tangent is opposite over hypotenuse, so it's also going to be a half. Opposite over adjacent. Whoops, what am I talking about? 1 over √3. Sorry, opposite over adjacent. I didn't write that properly here. So I've got my value, exact value for sine 30, cos 30, tan 30. I can also do the same for 60 because I established that I can have 60 down here. So I'm going to say sine 60, cos 60, and tan of 60 equals sine opposite over hypotenuse, so I'm going to 60, √3 over 2, and I repeat the process for all of these. So I'm getting exact values for all of these here by leaving it in surd form or leaving it as a fraction. And tan is going to be opposite over adjacent, which just becomes √3. So I've got exact values for all them there. But what about tan? Well, let's draw another triangle. But this time I'm going to draw an isosceles triangle, meaning this is going to be 45 degrees and that's going to be 45 degrees. Now, if they're both 45, we know both of these sides are going to be the same length. So I'm going to pick an easy value for the sides, 1 and 1. Both the length of those sides are 1. Now, I can also work out the hypotenuse by using Pythagoras to be √2. Now, I have 3 values there, so I can start looking at the tangent, the values for sine, cos, and tan for 45 degrees. So sine of 45 degrees is going to be opposite over hypotenuse, so it becomes 1 over √2. Cos of 45 degrees is going to be 1 over √2 again. And tan of 45 degrees is going to equal just 1. Okay. And that's how we derive our exact values. There's a trick you can do with your hand, but I'm not going to go over it here. But this is essentially why we have exact values. We know that sine 30 is always going to equal a half. We know that sine 60 is always going to equal the value of √3 over 2. The reason we use this is they're common angles we use in triangles, often when we move on to the unit circle. And that's what we're going to have a look at now. So with that knowledge under our belts, we want to move on and have a little look at the unit circle. Now, I apologize for my poor drawing skills in advance. I'll try and make this as neat as I can. But I'm going to draw a Cartesian plane like that. Try and draw a respectable circle. So, we're looking now at a thing called the unit circle. Now, the unit circle, we call it that because we're moving in values of exactly 1 unit. Okay, so what I'm going to do is I'm going to make the radius of this circle 1 unit. That's going to be 1, that'll be y, 1, that'll be -1, and that'll be -1 on the y. So our radius, pardon me, all the way around the circle is exactly 1 unit. That's why it's called the unit circle. What I'm going to do is, in this first quadrant, I'm going to draw a triangle, just to any point. I'm going to pick a point there, I'm going to go down there, and I'm going to complete a right angle triangle. I'm going to call that point on the circle. So remember, this is our x and this is our y-axis. I'm going to call that x and y. If I call that x and y, it means I've gone x units across, and I've gone y units up. Okay, x and y. I've gone x across, y up. And I'm also just going to put a random angle in there. Say theta's sitting in there. All right. I also know that my hypotenuse is going to be 1 because it's the radius of the circle. With this knowledge, I want to come up with a value for sine theta, cos theta, and tan theta. So sine of theta here, so we know that sine using SOHCAHTOA is opposite over hypotenuse. So my opposite here is going to be y. Now hypotenuse is going to be 1. So our sine theta is just going to be y. Cosine theta is going to be adjacent over hypotenuse. So it's going to be x over 1, so it will be x. And our value for tan will be opposite over adjacent, so it becomes opposite, which is y over x. Now we actually have a value for y, and we have a value for x here. Our value for y, well, y equals sine of x, sine of theta over cosine of theta. Now, what can we actually do with this? Okay, we've established that instead of it being x and y, we have new values for x and y. The dot on this circle here could instead be represented by, my value for x is cosine of whatever the angle is, then sine whatever the angle is. So that is x, and that is the y value. It's a bit odd, but why do we really care about that? Well, our sine, cos, and tan, in terms of the unit circle, what I'm saying is cosine is the x-coordinate, and sine is the y-coordinate of theta, of a point of a unit circle. So that point there, with an angle, theta, between the positive x-axis and the radius to the point. So I'm saying the positive x-axis, starting here at 0 degrees, up to there, we can get our coordinates using cosine and sine of theta. How does this actually help us do anything? Right, well, if I was given the values of, if I said, what quadrant or what is the value, say, of sine 95? Sine 95. Usually we'd reach for a calculator to do it. But here's what I'm going to do. I'm going to make an estimate. I'm saying that 95 degrees, so starting 0 here, 95 degrees is going to fall about, I don't know, here on our unit circle. Okay, let's draw that going back to the start. So that there is about 95 degrees. Here, I've asked for sine of 95. We know that the x-coordinate is the cosine value for 95, and the y-coordinate is the sine value for that. So I'm looking at the y-coordinate of this little dot here to see what sine of 95 actually is. it's not going to fall very far below our 1 value on the unit circle. So I'm going to guess that my sine of 95 value is going to be really high, really, really close to 1. I'm going to guess it's about 0.98, something like that. Because I've started going back down the circle a bit, but I haven't dropped very far from the y-axis. And we established the y-axis is the sine value. So that's my guess. So if I get my calculator now, and I put it in a calculator, I say sine of 95. It's about 0.99. Oh, I was a bit off. So it's actually 0.99, something like that. But I'm able to guess really closely what values of these are actually going to be. And if you look, I can find absolute values on here as well. So I know that sine of 0, so 0 degrees around, well, the sine value on the y-axis is going to be 0. So I know sine of 0 is going to be 0. If I looked at sine of 90, it's going to be the y value, so it's going to be all the way up here, exactly on 1. So I know it's going to be 1. Sine of 180. Now this is new territory because in triangles we never go past 180. We can't have an angle bigger than 180. It's impossible in a right angle triangle or a triangle or anything because the internal angles are 180. But I'm saying sine of 180 here. But I know sine of 180. Well, 180 is going to be all the way around here. I'm going to be back on 0 again. To prove my point, sine of 180 is 0. Okay, so we can use the unit circle to find our values for sine and cosine as well. So if I was looking for cosine, if I was looking for cos of, I don't know, 190, okay, I look at my unit circle, I start at my 0, I go around to 190. It's actually going to be about here, so I've come in a little bit. -1 down here, so that's going to fall probably somewhere about, I'm not really sure. So if I go back, it's not going to be too far in. It's going to be about negative. I'm going to go with my initial guess up here. I'm going to say cos of 190 is actually going to equal about 0.98. So if I put it in my calculator and I say cos of 190, now remember, I'm using the x value because cosine is on the x-axis. Negative, I forgot the negative because I've gone back down the negatives. Negative 0.984. So I was pretty much as close as I could be. Tan gets a little bit different purely because tan is sine over cosine. So if I wanted tan of, I don't know, 80, I need to get both values here. So on the, it's sine over cos, so my sine value is my y-axis. 80 is going to be about here, so it ended up being about 0.92 over, and our cosine value, once it starts to come back in, I don't know, it'd be about 0.3 or something like that. So if I did so something like that, I can find that there. Now we can actually find a tan's positive or negative, because if I had tan of, I don't know, let's say maybe 100, tan 100, it's going to be over here somewhere. So my sine value, which is going to go on top, is still going to be positive. It's going to be like 0. I don't know, 9 or something. But our cosine value is going to be back here a little bit. It's only going to be like 0.2, but negative 0.2. So if we're dividing by a negative number, the tan's actually going to be negative in some way. So if I did tan 100 on the calculator, it's going to be negative 5.67. Now, it's going to depend on how accurate that graph is, because mine isn't very accurate. So let me see what I got. So if I did that there, I'd get negative 4.5. But you can see I can place which quadrant it would be in, if it'd be positive or negative. And that's the gist of the unit circle.